Today we're going to be looking at quadrilaterals in the coordinate plane, and we're going to be proving using the coordinates of these quadrilaterals what the most specific type of quadrilateral is that we can classify this thing as. So here we go. Let me start off by saying these problems, if I work every problem in this lesson video, it's going to be very long. So what I'm going to do is just work one or two, let you see what's going on, get the hang of it, and then you're going to need to do the rest of them by yourself. I will have the solutions available, but really it's a simple matter of remembering our formulas for distance and midpoint. So we'll write those up here. The distance formula, you remember, is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Hopefully you've got an old note card with that formula on it somewhere. And the midpoint formula is x sub 1 plus x sub 2 divided by 2. Remember, we're essentially finding the average of 2 points. Y sub 1 plus y sub 2 over 2. I hope you remembered that. And stop for a minute and think, why might we need to know this? Also, we're going to use slope a lot, and we need to remember that lines that are parallel have the same slope, and if the lines are perpendicular, they have the negative reciprocal or opposite reciprocal slope. So think about that for a second. Why do we need this old information that we learned ages and ages ago to prove something about quads in the coordinate plane? Well, because if we can show that opposite sides are parallel by using slope, then we know we've got a parallelogram. Okay, then we could maybe use the distance formula to find out what sides are congruent or not. And then the midpoint formula, how would that help us? Well, how about in terms of deciding whether the diagonals bisect each other? Okay, so that's all we're going to do, use things that we've known for a long time. So let's just hop right in here and start. This quadrilateral, you know what, I'm not going to do this first one here. You can go back and do it because the vertices aren't labeled and I just have to count what they are, and I don't feel like counting right now. So I'm going to start with number 1 here. I'm going to draw myself a little sketch over here. Let's see, I got 9. The farthest it goes out is 9. So I'm going to start it over here like so. Okay, A is 9, negative 4. So I'm just eyeballing this. 9, negative 4. There's A. B is 8, negative 2. So there's B. C is 2, negative 5. That's going to be a little bit below that. There's C. And D is 3, negative 7. So 3, that's farther on down here. So I'm going to say about right there. That's D. Okay, then I'm going to sketch my quadrilateral. And even if you're using graph paper, you're not going to just say, oh, well, I can tell because it looks like a rectangle. It's a rectangle. You have to do the algebra. The one above here, it looks like a parallelogram, but you have to do the actual algebra. So let's come here and see what we got. First, let's decide if this is a parallelogram. So let me find the slopes of the opposite sides. So I'm going to start with AB. The slope of side AB is negative 2 minus negative 4 over 8 minus 9, right? And that is 2 over negative 1, so negative 2. All right, and then let me find the side opposite AB, which is CD. The slope of CD is negative 7 plus 5 divided by 3 minus 2, so negative 2. So yay, so far so good. I've got opposite sides parallel, one set of opposite sides parallel. What if that's all I find? What if the other two sides aren't parallel? What's it going to be? Oh yeah, trapezoid. But let's go ahead. We can't stop here, so let's come on. I'm going to run out of room, I'm afraid. So let me come on over here and find the slopes of the other two opposite sides. So BC, the slope of BC equals -5 plus 2, which is -3, and 2 minus 8, which is -6, so positive a half. All right, and the slope of AD, and I'm just looking at my coordinates here that I'm given. So the slope of AD is -7 plus 4, so -3, and 3 minus 9, which is -6. So that gives me a half. So definitely a parallelogram. Definitely a parallelogram because opposite sides are congruent. But hey, look at these slopes here. They're negative reciprocals, aren't they? The adjacent sides have negative reciprocal slopes. So what does that tell me? That tells me I got 4 right angles here. Yep, 4 right angles, so definitely it's a rectangle. It's a rectangle, but can I stop? No, I can't stop because once I know it's a rectangle, I got to check to see if it's a square. Okay, now I'm pretty certain this thing isn't a square by the way it looks, but like I told you a few minutes ago, you can't go by looks. I have to decide if it's a square. So how am I going to do that? I'm going to find the lengths of my sides. So okay, I'm going to do this whole problem right here without pausing. Probably throughout the rest of the problems, I'm going to pause and write the answers because, as I said, otherwise this video will be 45 minutes. But we'll do this one and then I'll do some pausing in the other ones. So we want to find the lengths of sides. So let's just find AB. Let's find the length of AB. It's going to be x sub 2 minus x sub 1. So that's 1 squared here, plus -4 plus 2, that's -2 squared, which is 4. So that's the square root of 5. And I am doing this in my head, AB. So let's do CD. CD is CD. Okay, I got 2 minus 3, which is -1, so that's 1 squared. -5 plus 7, so that's 2 squared. So there's the square root of 5. Things are looking good. Well, hey, do I have to do the, you know what I should have done? I already knew it was a parallelogram. So I knew that AB was going to be congruent to CD, right? So I should have done 2 consecutive sides or 2 adjacent sides. So I wasted my time right here doing this because I already knew that, right guys? So what I'm getting at here is doing these takes a little practice, and once you've practiced, you start realizing that you can take shortcuts. Oh, I don't have to find the lengths of all the sides because I already know the opposite ones are congruent because I've already proved it's a parallelogram. So let me just go and see if AB is going to be congruent to, let's say, BC. So let's find the length of BC. Let's see, what do we got? We got 8 minus 2, which is 6, so 6 squared. And then we've got, well, I already know those aren't congruent, but I'll just put it in here anyway. -2 plus 5, so that's going to be 3 squared. So that's the square root of 36 plus 9, which is 45, so definitely not a square. So the most specific classification I can give to this quadrilateral is a rectangle. All right, and that's how you're going to do every one of these problems. Okay, let's see what comes next. See, just a bunch more of these. I'm going to flip through here and just see if there's anything unusual. There's another one, so 2, 3, 4 the same. What's the most precise classification? I was just seeing if that was the last one. What's the most precise classification of the quadrilateral formed by connecting the midpoints of this kite? Well, I got to find the midpoints first, right? So what I'm going to do here is I'm going to find the midpoint of IT, and I'm going to find the midpoint of ET. Going to find the midpoint, and I'm using capital M, you realize here, because I'm looking for the midpoint, not the slope. And then I need the midpoint of KE. Well, shoot, I'll call it EK. And then I need the midpoint of IK. And so I'm just going to set this up for you, and then you're going to do it. And what you're going to find is that's going to be right there, that's going to be there, there, and there. So then I've got this quadrilateral right here, and then you're back to doing just what I did in the first problem for you. Okay, so let me just label these vertices for you, and then what I think I'm going to do is I'm just going to turn you loose to work these problems. Please do them. Please do them all tonight. Then when you get to class, I'll give you a few more to practice, but you might not need to practice them, okay, if you do all these. So let's see, 2, 3, 4. So I is 0, 4. T is 4, 5, 6, 7, 8. 8, 0. When I give you the quadrilateral on the coordinate plane, you really have to label the vertices or you're very likely to make a mistake. 2, 3, 4. So negative, not negative 4, 0. 0, negative 4. And then K is going to be 1, 2, 3, 4, negative 4, 0. So you can use those coordinates to verify where I put my midpoints. For instance, if I look at IK, I can see that I'm going to say negative 4 plus 0 divided by 2. That's going to be negative 2. And then my y coordinates are going to be 0 plus 4 divided by 2. So that's positive 2. So you can see I do have my midpoint there put in the right place. So I want you to do this for the rest of these problems. I will post the solutions on Blackboard for you. I don't know if I'm going to fill them in on this video or maybe just post the answer key, but let me see what's coming next here. Oh yes, I do need to go over this with you. Suppose I don't have numbers. I give you letters, okay? And this is something that you do have to do from time to time. Probably could expect to see a problem or two like this on your test. So let's figure out how we do this. SQRE is a square, okay? So I know all the sides are congruent. I know that I have right angles at each vertex. SQ, so the length of SQ right here is 2a. The axes bisect each side. So we want to find the vertices. Okay, so let's think about R here. Let's start with R. Okay, if SQ is 2a, then I also know that ER is 2a, correct? So that means half of it would be A. So that means I have to come over A units, right? To get to R, I have to come over A units. Each side is actually 2A. So that means I have to go to the right A units and I have to go down A units, right? If that whole side length is 2A. So let's look at Q then. I know the X value is going to be the same. That's not negative. Let me get rid of that so I don't confuse you. It's not negative. ER equals SE equals SQ equals QR, and they all equal to A. Okay, so now let's look at the coordinates for vertex Q. Once again, my X value is going to be A, and how high am I going? Well, I'm going up A, right? Going up A units. So if I look at the total length of QR, it's going to be this piece right here. This piece right here is A units long. This piece right here is A units long, which makes the whole thing 2A units long. Okay? And then for S, I got to go negative A units. So I'm going left A units and up A units. And then for E, I'm going left A units and down A units. So there are the vertices. Okay? How about this one? RECT is a rectangle with a height of A. Okay, if its height is A, then what do I know right off the bat? I know that Y value for E and C are both A. The length is 2B. The y-axis bisects EC and RT. Okay, this whole length here is 2B. So that means this piece is B units long and this piece is B units long. So why don't you take a second and try to find what those vertices are. I'll pause and fill it in. Okay, there you go. There are your vertices for that rectangle. What have we here? The diagram below shows a trapezoid with the base centered at the origin. And they've given you the vertices, and they want to know, is it an isosceles trapezoid? How are we going to find out whether it's an isosceles trapezoid? We got two choices here, right? I could find out if RT equals AP, right? Because if it's isosceles, they'll be congruent, so their lengths will be the same. Or what could I do with the diagonals? I could find out if they're the same length too, right? I could find out if RP equals AT. So I think the way I did it when I worked my key is I used the diagonals. So here's what I did. I said RP is the square root of x sub 1 minus x sub 2. So that's negative b minus a squared plus c minus 0 squared. All right, and when I simplify that, I get negative b minus a squared plus c squared. Please do not think you can take the square root of both of those parts under there and say that, oh, okay, that's negative b minus a plus c. No can do. All right, let's see what AT is. AT is negative a, or b plus a, I guess I should say, b square root of b plus a squared, and then I've got c minus 0 again, c minus 0 squared. So I have b plus a squared plus c squared. So, are those two things the same length? I'm going to leave you with that little challenge to figure out and explain to me if these two are the same. Then I want you to write an explanation. Since most of you don't write summaries anyway, some of you do, and they're beautiful summaries, but some of you don't. So if you're going with this, explain why those two things are equivalent. All right, if you don't care to explain that, then what I want you to do down here in your extra space, down here, is I want you to show using the distance formula that RT equals AP. So do that for me. I'll post the solutions to the rest of these problems on Blackboard, and you have a nice night.